cubical tank of 2 meter slides is constructed in metal plate 12 mm and contains water at 75 degrees Celsius. The surrounding air temperature is 16 degrees Celsius. Calculate the overall heat transfer of coefficient from water to air. Take the coefficient of thermal conductivity of metal as 48 watts per meter Kelvin. The coefficient of heat transfer of water is 2.5 kilowatts per meter squared Kelvin, and the coefficient of heat transfer of air is 16 watts per meter squared Kelvin. Now, we have our given here. So, our area, we can have 16 meters squared, and for our temperature initial, we have 75 degrees Celsius, and for our temperature 0 is equals to 16 degrees Celsius. And for our thermal conductivity, we have 48 watts per meter Kelvin. And our H1 or heat transfer 1, we have 2.5 kilowatts per meter squared Kelvin, or 2,500 watts per meter squared Kelvin. And for our heat transfer 2, we have 16 watts per meter squared Kelvin. This 2.5 or 2,500 is the heat transfer of water, and this 16 is the heat transfer of the air. So now, let's compute the overall heat transfer of coefficient from water to air. So we have here our equation. Heat transfer is equals to the overall heat transfer multiplied to area times temperature times the change in temperature is equals to change in temperature over length is equals to E, which is the thermal conductivity over thermal conductivity times A plus 1 over H1 times area plus 1 over H2 times area. So we have here the overall heat transfer coefficient times area times change in temperature is equals to change in temperature times A over length times thermal conductivity plus 1 over H1 plus 1 over H2. H1 is the heat transfer from water and H2 from the heat transfer of air. So U is equals to 1 over, since we have the length of 0.01, and for our thermal conductivity of 48, this one, plus 1 over this one, we have the H1, which is the heat transfer of water, plus 1 over 16, which is the heat transfer of air. So let's solve this and plug in to our calculator. We shift solve, we can have the overall heat transfer of 15.846 watts per meter squared Kelvin. So this is the result.